For number 8, we want to solve 3 log base 4 of 6x equals 9. So we're going to start by getting rid of that 3. We don't really need it there. We can divide both sides by 3. So we have log base 4 of 6x equals 3. Now, there's not much else we can do here. It's not the one-to-one property. So let's rewrite it in exponential form, see if that helps. So 4 to the third equals 6x. So 4 to the third equals 6x. Oh, that we can probably solve. 4 to the third is 64. And then we just need to divide both sides by 6. And we get 64/6, which that reduces to 32 over 3. All right, we're going to solve number 9. It also gives us a little hint to check for extraneous solutions. So we'll get to that at the end. Let's see. Well, we've got 2 logs on this side. Let's combine these. Remember, in logarithms, adding means multiplying. So we have log of x times x minus 9 equals 1. This is not the one-to-one property because I only have one log on the left. I don't have a log on the right. So maybe exponential form will help. Remember, this is log base 10. So 10 to the first equals all of that. So 10 to the first equals x minus 9. So that means 10 equals x squared minus 9x. Oh, that's going to be a quadratic. Subtract 10 over to the other side. We should be able to factor that. So our solutions are 10 and -1. Now, it does say to check for extraneous solutions. Remember, we are not allowed to take the log of a negative number. So right here, we need to make sure we're not plugging in a negative number. Of course, plugging in 10 is going to be fine, but I can't plug in -1 there. So that's an extraneous solution. The only solution we actually have to this problem is 10. All right, last one. We're going to invest $500 at an annual interest rate of 5.25% compounded continuously. That means we're using the PERT formula for this. We want to know how long it'll take our money to double. So how long we are trying to solve for t. So our principal, that's $500. That's what we're investing. Our rate is 0.0525. T is what we're trying to find, the time that it takes it to double. So if we double $500, we now have $1,000. Okay, so this is the equation we're going to solve. So I'm going to start by dividing both sides by 500. So I get 2 equals e to the 0.0525t. Now, we could rewrite this in logarithmic form. Let me show you the other way I like to do this. The t is in the exponent, and I want to bring that down. So the only way I can bring that down is if I take a logarithm, okay? Because remember that I can use a down and front property. So I'm going to take the natural log here and here. I'm going to take the natural log. I have to do it to both sides. We'll bring that down in front. So that gives me natural log of 2 equals 0.0525t times the natural log of e. Now, the natural log of e is just 1. We don't really need it in the problem. So all we have to do now is divide by 0.0525. And that will give us our answer for t. We got to grab a calculator here. Looks like 13.2 years. So when you're solving these logarithmic and exponential equations, you have several different strategies. You can maybe use the one-to-one, but really the 2 strategies that we're using the most are rewriting either in exponential form or logarithmic form, and moving back and forth gets us a lot of places. You can also use the down and front properties. Remember, you have to take the log of both sides to use that.